completely become oxide, and then how it will influence the overall performance?
That's a great question. We're fairly certain that it's only the top layer that's being converted to an oxide, and that's because of a couple of reasons. We do some. I haven't shown the results here, but if you do optical measurements like Raman and photoluminescence spectroscopy, there's some quite clear characteristics of, or you can calibrate the thickness of your tungsten diselenide to your Raman or your photoluminescence signal. And so if you then compare your wafer, your flake before you oxidize it, and then afterwards you'll see that you transition from either 2 to 3 or 3 to or 2 to 1 or 1 to 0. And so these results prove that we've got just a single, it's self-limiting to a monolayer. So far we've tried oxidation times up to 5 minutes, and they've all been consistent with that. In our case, we only really want the top layer being oxidized is enough. If you do your oxygen plasma process and heat the substrate at the same time, it is possible to create a thicker oxide. But for us, that so far wouldn't be useful. We get a high enough doping level without.
Thank you.
Okay.
Actually, I have a similar question. When you introduce oxygen to your 2D material, you create more, you change your material into p-type. It's gonna damage or degrade your hole mobility, for example, or change the band gap of the 2D material?
So far, in our measurements, we see an increase in the mobility before and after the oxidation, and the mobility increase is because we have the higher carrier concentration. In terms of damage, because we see the increase in mobility after oxidation, then that's enough proof for us that we haven't significantly damaged, that this process isn't damaging the sample. Now, we use a very, very low power to do this oxygen plasma treatment very deliberately, so it's only 10 watts, so the lowest power setting on the system, just to keep it as gentle as possible to prevent any damage.
Okay. Any other questions? No? Okay, let's thank our speaker again. Thank you. Thank you, Luke.